To understand kVA and kilowatts better, look at this picture up here. You see a cup of beer. You see where it is labeled kW, you will see kVA and you will see kVAR. Like I mentioned on the last video, kW, which is the kilowatt, is the real power, the actual power you can use. That's the actual content on this bottle that you can drink, the drinkable beer, the one that you drink and it will chill your chest. Yes, that is the real power, that is the kilowatt. Then the kVA is the total. You can see there is a foam at the upper section of the cup. How does that foam come about? When you are transferring that beer from the bottle to the cup, it is reacting with that flow, forming that foam, and that becomes a waste. You know, I mentioned earlier that when you are transmitting an image or transforming it, there's always a wastage. So that wastage is that foam on that beer. And usually when that foam forms, you just blow it away and drink the real content, which now is the kilowatts. The kVA is then the total, both the kilowatts and the wasted one, which is the real beer and the foam, which you're not drinking. That is the kVA. Then the kVAR is only the reactive power, which is that foam alone. That unit is only measuring what is being wasted. In most power generations, the efficiency power factor there is 0.8. It is rated from 0 to 1, but the standard and usual power factor efficiency is 0.8. So you can see that on that whole cup of beer, the wastage, that is the foam, is about 20% of the entire size. You understand? That is that the real power is 0.8 and the remaining one is 0.2, which is the waste, which is now the kVAR. I hope after seeing this, you now understand the difference between kVA and kW. So it is usually 0. Whenever you hear kVA, you can times it to 0.8 to get the actual power that you can use. So when they are saying this generator is 10 kVA, just times it by 0.8 to get the actual power, which is about 8 kilowatts, which is 8,000 watts. To understand kVA and kilowatts better, look at this picture.